Good evening, everyone. A very good evening to all of you, bacho. We are live. We are back on ExamDost. We are back with the rank improvement course on power electronics, lecture number 4. That is the last lecture of the first unit, Thyristors part 2 and your diode circuits. So quickly, everybody join. Come on, everyone. We are about to start the last lecture of the first unit. So everybody join the session. Chalo. So let us review what we covered yesterday. Yesterday we covered SCR. So SCR is a 4-layer 3-junction PNPN device having 3 terminals, anode, cathode, gate. SCR can be turned on using a positive gate pulse, but it cannot be turned off using the gate terminal. Rather, it has to be turned off just like a diode by reducing the current to 0 and then reverse biasing the device. Now, it has 3 operating mode. Okay, it has 3 operating mode: reverse blocking, forward conduction. In reverse blocking, outer junctions are reverse bias. Okay, and the inner junction is forward bias. So the anode to cathode voltage is negative and diode works in reverse bias. Forward blocking, outer junctions are forward, inner is reverse. So anode to cathode voltage is positive, but it is on. So it will stay off, until your gate current arrives. Forward conduction, all 3 are forward biased. So all 3 junctions are forward biased, means the 2 BJTs inside the SCR are working in saturation region. Now, beta, we can model the SCR as 2 transistors, one PNP and one is NPN. So, once you provide the gate current, one transistor starts to conduct. Current of one transistor will turn on the second transistor, which will increase the current of the first transistor, which will increase the current of the second transistor. That way, they will increase each other's current and current will go on increasing. Latching current is the minimum current during the turn on of the SCR, beyond which we can remove the gate pulse. SCR will stay on. So once SCR anode current crosses the latching current, you can remove the gate pulse. Holding current is observed during turn off. Once the anode current is reduced below the holding current, the SCR turns off. Now, during the turn on time, there are 3 time: delay time, rise time, and spread time. During delay time, current rises from 0 to 10%. It depends on gate current and dig by dt. During rise time, current of anode rises from 10% to 90%. It is dependent on the time constant. During spread time, current goes from 90% to 100%, and it depends on the geometrical construction of the device. During turn off, we talk about the device turn off time being combination of 2 time: reverse recovery time, which is same as a diode, and gate recovery, during which we remove the stored charges from the gate. So TQ is the minimum time for which you need to reverse bias a SCR in order to remove all the stored charge carriers. And TC is the actual time for which a SCR is reverse biased in a circuit. So for successful commutation, TC should be greater than TQ. Now, triggering methods are forward voltage triggering, where we keep on increasing the voltage until J2 breaks down. Second is the gate triggering, where we apply a gate pulse to trigger the SCR. Now, beta, in gate triggering, we can remove the gate pulse. Once the current reaches the latching current. So, we can use the pulse gate triggering. And in that also, if you use the high frequency pulses, you can reduce the size of the pulse transformer. dV by dt triggering, if the rate of change of anode to cathode voltage is high, it causes a high charging current of the capacitor. And if it is more than latching current, SCR will turn on. So this is undesirable, and to protect against this, we use the RC snubber circuit. In thermal triggering, if you increase the temperature, charge carriers are generated in the gate region. They will act as the gate current and trigger the device. It is undesirable. because it can damage the device or change the characteristic. In light triggering by the method of photoelectric effect, we can generate the charge carriers in the gate region to act as the gate current, and this is a desirable method used in a light activated SCR, and we can trigger multiple SCR using the same source. In the protection, overcurrent protection, we can use a fuse in series with the SCR, which will blow before the SCR is damaged. And SCR itself can protect a power converter using crowbar protection. For over voltage, we connect a varistor, which is a metal oxide resistor, across the SCR. For high di by dt, either use a center gated SCR, use a interdigitated structure, increase the gate current, or use a series inductor. Then high dV by dt, we can use a snubber circuit, which is a combination of R and C. How to find the value of C? dV by dt rating should be greater than equal to Vs upon RL. C. RL is the load resistance. C is the sum of snubber capacitance and the junction capacitance. And RS is designed to limit the maximum discharging current. For gate protection, to protect against high current, we use a series resistor. High voltage, we use a Zener diode. And then to protect against the electromagnetic interference, we use a RC filter. And for thermal protection, we mount the device on a heat sink, which increases the heat radiation to the atmosphere and does not let the heat accumulate within the device, so that temperature is controlled. Okay, so RC snubber circuit is placed across SCR for dV by dt protection. So capacitor opposes the change of voltage and reduces dV by dt. For junction temperature, how you can model it? You can model it as Tj equal to the ambient temperature plus average power into the thermal resistance. Thermal resistance is sum of three resistance: junction to case, case to sink, sink to ambient. Okay. SCR rating, on state voltage, which is the voltage drop across the SCR when it is conducting. dV by dt, maximum dV by dt it can tolerate without triggering. DI by dt rating, beta. DI by dt rating, basically the maximum DI by dt it can tolerate, because at high DI by dt there is a chance of formation of a local hotspot which can thermally damage the device. Latching current, holding current, average current rating, the maximum amount of average current it can tolerate, it is based on the amount of conduction losses. So the average current rating of SCR remains the same irrespective of the waveform, but RMS has to be decided from the average using form factor. Surge current rating, SCR can tolerate very high current for a short duration of time, that is called as surge current, and I square T should be constant. In the series connection, beta, there is a problem of unequal voltage sharing, for which we connect a resistor where the value of resistor is N VBM minus Vs over N minus 1 delta IB, or unequal reverse recovery charge. For that, we connect a capacitor whose value is given like this. In parallel operation, there is a problem of unequal current sharing. The second problem is unequal temperature, for which the devices should be mounted on the same heat sink. String efficiencies, actual rating of series or parallel combination divided by number of thyristor into rating of each thyristor. And D rating factor is 1 minus efficiency. Okay? Anji. Is this the last lecture of semiconductor devices? Yes. और N कन्नूर भाई PDF अपलोड हो गई हैं. जस्ट बिकॉज आप ढूंढ नहीं पाए, इसका ये मतलब नहीं कि अपलोड हो जाएंगी. और आप एक चीज बताओ, ऐप पे आपको कहाँ मिलेंगे? ऐसा तो है नहीं ऐप पे गए और होम पेज पे बड़ी सी PDF बन के आ रही है. ऐप पे जाएंगे, फिर क्या करेंगे देखिए जरा, दिखा देता हूँ. अब आप लोग क्या यार बेसिक चीजें ही नहीं चलाना जानते हो. हम लोग ये गए एग्जाम दोस्त पे, ठीक है. अब यहाँ पे हमें कहाँ मिलेगा फ्री कंटेंट? फ्री डाउनलोड्स में ही मिलना चाहिए. ये लेक्चर आप कहाँ देख रहे हो? यूट्यूब पे देख रहे हो तो यूट्यूब लेक्चर पीडीएफ में जाना चाहिए अपने को। ये लेक्चर किसका है? गेट का है या एजेई का है? सर गेट का चल रहा है। क्या ये फुल कोर्स है या ये क्रैश कोर्स है? ये क्रैश कोर्स है सर। क्रैश कोर्स किस सब्जेक्ट का है? सर पावर इलेक्ट्रॉनिक्स का है। और ये किसके पीडीएफ पड़े हुए हैं? पावर इलेक्ट्रॉनिक्स के पड़े हैं भाई। इतना सेल्फ एक्सप्लेनेटरी है कि थोड़ा सा वेबसाइट को एक्सप्लोर करोगे तो आपको मिल ही जाएगा, पर थोड़ा तो इतना बुद्धि लगाना चाहिए। चलिए, नाउ आई विल मूव टू द नेक्स्ट टॉपिक, दैट इज द थायरिस्टर गेट कैरेक्टरिस्टिक। Now, beta, the gate cathode junction is nothing but a PN junction. Okay, gate cathode junction is nothing but a PN junction. So the characteristic of the gate voltage and the gate current are similar to a diode. But sir, this is not how a diode graph looks like. Beta, it is looking like this because on y-axis I am taking voltage and on x-axis I am taking the करंट। मैं यहाँ पे एक्सेस पलट दिया हूं, वाई एक्सेस पे वोल्टेज है, एक्स एक्सेस पे करंट है, इसीलिए ऐसा ग्राफ आ रहा है। जब वाई पे करंट, एक्स पे वोल्टेज होता है तो ग्राफ एक्सपोनेंशियल आता है। नाउ वाई देयर आर टू ग्राफ? बिकॉज ऑफ द डिफरेंस इन द डोपिंग ऑफ द गेट एंड द कैथोड रीजन, द ग्राफ इज स्कैटर्ड। ग्राफ आपका फैला हुआ होता है क्योंकि गेट और कैथोड की डोपिंग अलग अलग हो सकती है। Now there are different limits: maximum voltage, minimum voltage, maximum current, minimum current, and the maximum power. You know, when you plot maximum power on IV axis, the graph is a rectangular hyperbola. मैंने आपको पहले ही बताया था, जब मैक्सिमम पावर करंट वर्सेस वोल्टेज पे ड्रॉ करें तो हाइपरबोला आता है, और लॉग वाली एक्सिस पे ड्रॉ करें तो आपका स्ट्रेट लाइन आता है। So this entire shaded area is the operating region. That means beta, your gate current and gate voltage can lie anywhere within this area. ठीक है? VG and IG can lie anywhere within this area. ठीक है? Now the triggering circuit is very simple. I have a battery, beta. I have a battery. I have a resistance. This resistance basically limits IG. Okay. And this is connected between the gate and the cathode. Now I can write the KVL equation of this circuit as VG equal to ES माइनस IG RS। तो मैं इक्वेशन लिख सकता हूं VG इक्वल टू ES माइनस IG RS। दिस इज कॉल्ड एज द लोड लाइन विच इज प्लॉटेड लाइक दिस। ये एक लोड लाइन है। नाउ बेटा, द कैरेक्टरिस्टिक इज ऑलवेज स्प्रेड बिटवीन द टू ग्राफ। So the middle graph is the characteristic, the lower and the upper graph are the limits। एससीआर की गेट कैथोड कैरेक्टरिस्टिक हमेशा दो कर्व के बीच में होती है, तो दिस इज द एक्चुअल कैरेक्टरिस्टिक, द लोअर एंड द अपर आर द लिमिट। So when you take the intersection of the load line with the characteristic, you get the operating point. That is, you get the value of VG and IG. So this characteristic beta, it is expressed as VG as a function of IG. ये जो आपका ग्राफ है, ठीक है, ये जो आपका ग्राफ है, ये मिलेगा VG एज अ फंक्शन ऑफ IG। प्रियांक भाई, RIB का जो इस साल का वर्जन है वो परचेज करोगे, उसमें YT70 लगेगा ना। ओके, तो नाउ दिस इज गिवन एज VG एज अ फंक्शन ऑफ IG। द सेकेंड थिंग दैट वी नो इज द पावर इक्वल टू VG IG। तो रिमेंबर, यू कैन फॉर्म थ्री इक्वेशन: लोड लाइन, द डिवाइस कैरेक्टरिस्टिक, and the power and your power. Now in power there are two possibilities: whether do I use the maximum power or do I use the average power. For maximum power beta, pulse width should be less than 100 microsecond, and for average power pulse width should be greater than equal to 100 microsecond. यानी पीजी में कौन सा वैल्यू डालेंगे? एससीआर का जो मैक्सिमम पावर रेटिंग है या एवरेज पावर रेटिंग, वो डिपेंड करता है पल्स विड्थ पे. ओके, नाउ नेक्स्ट आई कम टू द डिवाइस कॉल्ड एज जीटीओ. GTO is my gate turn off thyristor. Now beta, the change in the structure, listen to me carefully. Now in the anode region beta, it is not completely P plus. We have inserted small N plus region and the gate has been highly doped. मैंने दो चेंजेस किए, गेट का डोपिंग मैंने बढ़ाया और एनोड में मैंने N प्लस रीजन इंसर्ट कर दिए P प्लस के अंदर. तो दिस बिकम्स अ GTO. द रिप्रेजेंटेशन इज सेम एज द SCR, but I show a small cut on the gate terminal or I show bi-directional arrow on the gate which indicates gate current can be positive or negative. ये एरो क्या दर्शाता है कि गेट करंट प्लस और माइनस दोनों हो सकता है. नाउ बेटा, व्हेन यू टॉक अबाउट टर्न ऑफ ऑफ अ जीटीओ, हाउ यू आर एबल टू टर्न इट ऑफ यूजिंग द गेट करंट. So first thing you should understand that the gate current of a GTO is very, very high. So to turn off a GTO, we have to apply negative gate current. That means gate current will be taken outside the gate terminal. Because the gate current is going outside, the base current of Q2 reverses. So Q2 turns off. And if Q2 turns off, the Q1 also turns off. Because base current of Q1 comes from Q2. जब आप गेट करंट को पलटते हैं तो Q2 का बेस करंट पलटता है, Q2 बंद हो जाता है और Q1 का बेस करंट Q2 के कलेक्टर करंट से आता है. तो अगर Q2 बंद हो गया तो Q1 ऑटोमेटिकली बंद हो जाएगा क्योंकि उसकी बेस की सप्लाई खत्म हो गई. बट GTO हैज अ वेरी पुअर टर्न ऑफ गेन. माने to turn off a GTO, you have to apply very, very high gate current. So the turn on or the turn off gain is the ratio of the anode and the gate current. So poor gain mane for same amount of anode current, how much gate current do you need? So poor gain mane we need very, very high gate current to turn off a GTO. Okay. Now switching characteristic beta, again you will see the turn on once the gate current reaches 90%. So now during turn on there are three times: the delay time, the rise time, the spread time. And during turn off there are three times: the storage time, fall time and the tail time. ये आप already पढ़ चुके हो बेटा. But the important thing is, unlike SCR beta, unlike SCR, you cannot remove the gate current after GTO turns on. ठीक है, IG cannot be made zero, cannot be made zero once SCR, once GTO is on. So minimum gate current has to be maintained, that is the back Porsche current. Okay. Is that clear beta? So that is the difference with respect to GTO. That is the difference with respect to SCR in case of GTO. Is that clear? Now, SCR has lower latching and holding current, GTO has higher. SCR has lower gate current, GTO has higher. SCR has higher rating, GTO has lower rating. SCR has less speed, GTO has higher speed. For turning off SCR, we need commutation circuit. GTO does not need any commutation circuit beta. Then SCR has less efficiency, GTO has more efficiency. Why? Because in SCR there are losses in the commutation circuit. SCR produces more interference. Okay. GTO produces less interference. SCR is bulky, GTO is compact. Okay, so size wise SCR is larger than GTO. ठीक है बेटा. Now next is ASCR, asymmetrical SCR. Asymmetrical SCR माने the reverse blocking capability of this SCR is much smaller than the forward blocking capability. So symmetrical SCR माने the forward breakover voltage and the reverse breakdown voltage are equal. But asymmetrical SCR माने forward breakover voltage is high, but reverse breakdown voltage is very low. So it is of the range 20 volt to 30 volt, whereas forward blocking 400 to 2000. Okay. Now, reverse conducting thyristor. Reverse conducting thyristor. Reverse conducting thyristor. It is a special SCR in which you are creating an integrated circuit in which you are fabricating a SCR and a anti-parallel diode on the same chip. Just like MOSFET has a body diode, here also you are creating an integrated circuit along with a anti-parallel diode. Now because of anti-parallel diode because of anti-parallel diode, the reverse blocking capability is reduced. That means the device cannot block reverse voltage. But it will be used in application where we need a reverse or anti-parallel diode like a voltage source inverter. Voltage source inverter में anti-parallel diode चाहिए होता है, वहां आप इस IC का इस्तेमाल कर सकते हैं. So this will lead to saving in the space. Why? Because now diode is fabricated on same IC. So you don't need to connect a diode externally. So you can save a lot of space and reduce the size of heatsink. So rating is 2000 volt 500 ampere. General meaning of DRF. DRF का मतलब होता है derating factor, यानी रेटिंग कितना रिड्यूस हो गई एक्सपेक्टेशंस. माने अगर सारे SCR अपने रेटेड वैल्यू पे काम करते तो ज्यादा रेटिंग मिलती. अभी सब लोग में अनइक्वल शेयरिंग हो रहा है. अनइक्वल शेयरिंग होने के कारण आपको जो रेटिंग मिलनी चाहिए आपको उससे कम मिल पा रही है, and that is called as derating factor. Okay. Next is DIAC. DIAC is like two anti-parallel SCR but without a gate terminal. Now because you do not have a gate terminal, you have to trigger any SCR using the forward breakover triggering, which means you have to exceed the breakover voltage to trigger the SCR. SCR को ट्रिगर करने के लिए आपको ब्रेक ओवर वोल्टेज एक्सीड करना पड़ेगा. तो बेसिकली यू हैव टू एंटी पैरेलल SCR. If you exceed the breakover voltage in the forward direction, it will conduct in the forward direction. If you exceed the breakover voltage in the reverse direction, it will start conducting in the reverse direction. बात समझ में आ रही है? जिस भी दिशा में आप ब्रेकओवर वोल्टेज एक्सीड करोगे, if you exceed in the forward direction, forward current will flow. If you exceed in the reverse direction, reverse current will flow. So basically it has identical characteristic in the first and the third quadrant, and you can see beta, there is one PN-PN structure, another PN-PN structure. So it is similar to two anti-parallel SCR. Many people confuse that it is two anti-parallel diode. No beta, it is two anti-parallel SCR but without a gate terminal. So that is also known as a gateless triac. Yani triac without a gate terminal, because triac also internally has two PN-PN structures or two anti-parallel SCR. इसीलिए triac terminals are named as MT1 and MT2, not as anode cathode. Anode cathode नहीं बोलते. Main terminal 1, main terminal 2, and 1 is the gate terminal. Now मेरे बच्चों, if you see the gate terminal is connected to N of one thyristor and P of other thyristor. That means in the two PN-PN structure, for one SCR, P region will act as a gate which needs a positive gate current, and N will act as a gate for the other thyristor which will need a negative gate current. तो पॉजिटिव गेट करंट से एक पीएन स्ट्रक्चर को चालू करते हैं क्योंकि पी से जुड़ा है, और दूसरे का गेट एन है, तो वहां पे गेट एन से जुड़ा है, तो नेगेटिव गेट करंट से चालू किया जाता है. So if you want to conduct in the forward direction, you need positive gate current. As you increase the gate voltage, breakover voltage decreases. If you want to conduct in the negative direction, you need the negative gate current. As you increase the negative gate current, the breakover voltage is going to decrease. The next is the firing circuit. Okay. Now firing circuit is what? The circuits that we use to trigger the SCR. And remember beta, for triggering the Triac, we make use of DIAC. So let's quickly go through the firing circuit. The first circuit is called resistance firing circuit. Now what is resistance firing circuit beta? Here I have a supply, I have a load, I have a SCR, and in between beta, I have a network of the resistances which are being used to trigger the SCR. Now, why are we using a diode? So that gate current does not flow in the reverse direction. So, diode prevents reverse flow of gate current. Diode prevents reverse gate current. Now, beta, they are forming a voltage divider network. So, what is the voltage between gate and cathode? It is the voltage across R2, which is Vm sin omega t into R2 by R1 plus R plus R2. Voltage division. Okay? Now, this factor is written as VGM. Now, whenever the gate voltage becomes equal to the threshold, the SCR turns on. Whenever the gate voltage becomes equal to threshold voltage, that happens at an angle called as firing angle. Okay. So now what is the purpose of this resistance R? If you increase R, VGM decreases, so the firing angle increases. So the maximum firing angle as per sine inverse is 90 degree. Sine inverse का maximum value 90 degree होता है. So that is the maximum firing angle. That is the maximum firing angle which is 90 degree. If DIAC can only be triggered by breakdown, then why we use it? It is only used to trigger the Triac. Okay? So firing angle is the angle at which my SCR gets triggered after becoming forward bias. यानी फॉरवर्ड ब्लॉकिंग मोड में आने के बाद कितने एंगल के बाद वो ट्रिगर होगा, दैट इज फायरिंग एंगल. So purpose of R1 is to limit the maximum gate current. So if you assume R is 0, the maximum current will be Vm by R1. This should remain less than the maximum gate current specification of SCR. अगर R को 0 कर दो तो maximum current आ सकता है Vm by R1, जो SCR के maximum gate current से नीचे रहना चाहिए. Purpose of R2 is to limit the gate voltage below the maximum gate rating of the SCR. Maximum gate rating of the SCR. सर गेट से नेगेटिव करंट क्यों आएगा? बेटा एसी सप्लाई है ना, तो ड्यूरिंग द नेगेटिव हाफ साइकिल it can cause the flow of negative gate current because my supply is AC. Now understand beta, R2 will limit the gate voltage below the maximum gate rating of the SCR. Purpose of R, by varying R, we can vary the firing angle, and purpose of diode is to basically avoid the reverse flow of gate current. Okay? Gate current को पलटने से रोकना है. Now beta, as you can see, as I keep on increasing the R, the peak of the gate voltage keeps on decreasing. and the value of angle at which it intersects the threshold, it gives me the alpha. जिस एंगल पे थ्रेशोल्ड को कट करेंगे ग्राफ, वहां से अल्फा मिलेगा, एंड मैक्सिमम अल्फा विल बी 90 डिग्री एट विच द गेट वोल्टेज जस्ट टचेस द थ्रेशोल्ड. ठीक है, जब गेट वोल्टेज जस्ट थ्रेशोल्ड को टच करेगा तब मैक्सिमम फायरिंग एंगल आएगा 90 डिग्री. Next is the RC firing circuit. So instead of using a network of resistances, I have a network of R and C. Now beta, here the better part is you can obtain firing angle even above 90 degree. आपको 90 से ज्यादा अल्फा मिल सकता है. So during the negative half cycle beta, capacitor is initially charged to a negative voltage. Now when the positive cycle comes, capacitor starts charging towards the positive value, and whenever the capacitor voltage exceeds the threshold voltage of SCR plus the diode voltage, the SCR turns on. क्या होता है, जैसे ही कैपेसिटर चार्ज होते होते कितनी वोल्टेज तक चार्ज हो जाए, इसका थ्रेशोल्ड प्लस डायोड का ड्रॉप, तब आपका SCR ऑन हो जाता है. ठीक है, तो बेसिकली व्हाट हैपेंस, ड्यूरिंग नेगेटिव साइकिल कैपेसिटर इज चार्ज्ड टू नेगेटिव वोल्टेज. ठीक है, तो एट t इक्वल टू 0 capacitor voltage is minus. Now during positive half cycle, capacitor charges towards positive value through R, and once VC is more than VGT plus VD, SCR turns on. ठीक है, now in this circuit beta, by varying R, we can vary time constant and rate of capacitor charging. ठीक है, कैपेसिटर की चार्जिंग का रेट वेरी कर सकते हैं. तो स्लो चार्जिंग मीन्स more time to reach VGT plus VD, which means more alpha. So that way beta, you can decide the value of alpha by varying the value of R. So the advantage is you can obtain alpha greater than 90. The third triggering method is using a UJT, which is a uni-junction transistor. It is a transistor which has only one PN junction. That is why uni-junction, एक ऐसा ट्रांजिस्टर जिसमें एकमात्र PN junction होता है, उसे कहते हैं uni-junction. Now beta, in uni-junction transistor, the advantage that we get short duration gate pulses. In resistance and RC firing circuit, the duration of gate pulse is larger, which causes more power dissipation at the gate. It reduces the efficiency. But in UJT firing, we get short duration pulses by which we can increase the efficiency. Okay. So now this is the symbol of a UJT, which is very similar to JFET. So emitter base, there is a diode, and then the base is entirely a N-type semiconductor. एक N-type semiconductor है जिसके दो तरफ दो टर्मिनल लगा दिए B2 B1 और बीच में एक PN junction बना दिया emitter के साथ. Okay, so we have a N-type semiconductor in which there is a small doping of P region, that is emitter, on both side of n-type semiconductor, I have two terminal B2 and B1. Okay. So now, beta, with the help of a RC circuit and a UJT, I can generate a triggering circuit. So basically, what happens? In this RC circuit, capacitor keeps on charging. As soon as capacitor reaches a voltage called as VP, VP is the specification of the UJT. Once it reaches VP, UJT turns on, capacitor discharges through R1, and the voltage of R1 triggers the SCR. So what happens is, देखिए, capacitor charges through R, ठीक है? Once VC equal to VP, peak voltage, which is equal to eta VBB plus VD. Okay. UJT turns on, capacitor discharges via R1, and the voltage V1 triggers SCR. So here eta is called as the intrinsic standoff ratio. It is basically the factor of voltage division between RB1 and RB2. RB1 और RB2 इसके इंटरनल रेजिस्टेंसेस हैं, उनका जो वोल्टेज डिवीजन का फैक्टर है उसको ईटा कहा जाता है. So the time period of this oscillator is RC ln 1 by 1 minus eta and frequency is 1 by T. Frequency is 1 by T. So you can be asked direct question based on this. And there is one more formula on which they can ask you a question. That the resistance, if you connect at the ammeter, this should be the range. Okay, you don't have to go too much into the firing circuit because till date they have not asked questions on this. आज तक फायरिंग सर्किट पे सवाल पूछा नहीं गया, लेकिन कुछ साल पहले, like 5-6 years ago only, they have introduced this topic in the syllabus. So you just remember the basic fundamentals. That is enough in case they ask a question. Okay. Now we talk about the diode circuit. Beta, when a diode is connected with a AC source and a inductor, so what happens in this situation is, suppose at t equal to 0, you assume that IL is 0, okay? And diode turns on during positive half cycle. ठीक है, आप मान लीजिए पॉजिटिव हाफ साइकिल में डायोड ऑन हो गया बिकॉज ऑफ फॉरवर्ड बायसिंग. तो द वोल्टेज अक्रॉस द इंडक्टर इज इक्वल टू द सप्लाई. इंडक्टर वोल्टेज बिकम्स इक्वल टू सप्लाई. तो DI इज Vm by L sin omega t dt, और Vm by omega L, I'm multiplying and dividing by omega sin omega t d omega. Now I want to know that current started from 0. Suppose at t equal to 0, current was 0, and at t equal to some time t or angle equal to omega t, current is I. So integration of sine is minus cos. If you put the limit 1 minus cos. Now 1 minus cos omega t, the speciality is it is greater than equal to 0 for all t. So diode never turns off. In power electronics, beta, whenever there is an inductor involved, you have to see the current for turn off of diode or a SCR. जहां भी कहीं इंडक्टर आ जाता है ना, वहां पे करंट के आधार पे बात करनी है कि SCR बंद कब होगा या डायोड बंद कब होगा. So because current never becomes zero or negative, the diode never turns off. So we say diode conducts for full cycle. ठीक है? Diode conducts for full cycle. Therefore, conduction angle is 2 pi. And diode always remains short circuit. So V naught equal to V in, which is sinusoidal. V naught किसके बराबर आ जाता है? V in के बराबर. तो देखो, that is why V naught is completely same as the input, and this is the diode current. It never becomes negative. So the average value of the inductor current is, average value is the constant term Vm by omega L. Peak value occurs at pi. At pi it will be 2 Vm by omega L. Pi पे आएगा 2 Vm by omega L. ठीक है? Now always remember, for DC or average value, inductor should behave as short circuit for DC. Short circuit माने the DC voltage across the inductor should be zero. इंडक्टर का डीसी या एवरेज वोल्टेज जीरो रहेगा, फॉर विच बेटा पी नॉट एरिया शुड बी जीरो. नाउ यू कैन सी द ग्रीन एंड द येलो एरिया आर गेटिंग कैंसल्ड. तो एरिया इज जीरो. हाँ, डायोड नेवर टर्न्स ऑफ. ठीक है? तो ऑलवेज रिमेंबर VL एवरेज इज जीरो. ठीक है? देयरफॉर area under VL is zero. This is called as volt second balance. जब भी प्योर इंडक्टर होगा ना, या सिर्फ अगर आप इंडक्टर पे ध्यान दें, तो इंडक्टर की वोल्टेज का इंटीग्रेशन जीरो आना चाहिए. ओके, इट शुड ऑलवेज बी जीरो. तो दिस इज द करंट बेटा. तो डायोड करंट डज नॉट रिवर्स, डायोड डज नॉट टर्न ऑफ. Okay, in power electronics, whenever you want to see the turn off of a device, check when does current become zero and it tries to become negative. हमेशा ये चेक करना करंट जीरो कब जा रहा है और नेगेटिव जाने की कोशिश कर रहा है, तब डिवाइस बंद होगी. Now this term is a DC current, this is AC, so average value is this. And what about RMS? RMS can be taken as Vm by omega L DC square प्लस AC स्क्वायर बाय 2, विच इज अंडर रूट 3 बाय 2. यही होता है ना RMS निकालने का तरीका, अंडर रूट DC स्क्वायर प्लस AC स्क्वायर बाय 2. RMS कैन बी मेजर्ड बाय मूविंग आयरन इंस्ट्रूमेंट and average by a PMMC instrument. And V naught is equal to V in, which is pure AC. Now, when you talk about diode with a pure capacitor, it is like a clamper. Basically, the capacitor charges to the maximum voltage and then the diode turns off. So what happens is, beta, when you take V naught equal to Vs, Vm sin omega t, the current is C dV naught by dt omega C Vm cos omega t. So cos omega t becomes negative for omega t more than pi by 2. So diode turns off. तो 90 डिग्री के बाद करंट नेगेटिव जाने की कोशिश करता है, तो यही मैंने दिखाया, तो डायोड ऑफ हो जाता है. So the diode voltage then becomes, because capacitor is charged up to Vm, diode voltage will be supply minus V naught or Vm sin ओमेगा टी माइनस 1. ठीक है? तो ये जो साइन ओमेगा टी वाला ग्राफ है, इसको Vm नीचे शिफ्ट कर दीजिए, तो यू विल गेट द डायोड कर्व. तो डायोड ऑलवेज रिमेन्स रिवर्स बायस्ड. डायोड हमेशा किस में चला गया? रिवर्स बायस में. कभी ऑन ही नहीं हो पाएगा. So once the capacitor charges to the peak voltage, diode will permanently be off. Now LC oscillator beta. LC oscillator, first you have to understand how to form the equation. If capacitor is initially charged to a voltage V naught, and there is a supply Vs. Now forget about diode right now. Forget about diode. Tell me beta, if I want to ask you the steady state, what you will do? You will say inductor short circuit, capacitor open circuit. So steady state current of inductor 0 because capacitor is open. Steady state voltage of capacitor equal to supply. यही बोलोगे ना? मैं आपसे इस सर्किट में स्टेडी स्टेट अगर मांगता हूं तो आप कहेंगे सर इंडक्टर शॉर्ट कैपेसिटर ओपन. कैपेसिटर ओपन इसीलिए करंट 0 और क्योंकि कैपेसिटर ओपन तो उसके अक्रॉस पूरा सप्लाई आ गया. Now, whenever you see the steady state value of IL or VC becoming non-zero, use the function 1 minus cos with it. अगर आपकी steady state value non-zero आ रही है, चाहे IL की, चाहे VC की, आप उसमें कौन सा फंक्शन मल्टीप्लाई कर दो? 1 minus cos. तो VS 1 minus cos. Now, initial capacitor voltage is V0. Whenever you see initial voltage, multiply it by cos. Multiply it by cos. Now, if voltage contains cos, current will contain sine. So, beta, Vs will try to flow the current clockwise from the positive terminal, while V0 tries to flow the current anti-clockwise. Vs clockwise ले जाना चाहता है और V0 उल्टा ले जाना चाहता है. So, both the currents will be subtracted. Remember, if voltage contains cos, current will contain sine, and there will be two current due to Vs clockwise, due to Vc anti-clockwise. So the first current would be beta, the first current would be Vs, this is clockwise, y root C by L to make voltage into current. And the second current will be anti-clockwise. So what is this root C by L beta? Root C by L is 1 upon impedance. From power systems you know na, surge impedance is root L by C. Power system से आप जानते हो ना, surge impedance root L by C होता है. तो अगर मुझे वोल्टेज से करंट में आना है तो इम्पीडेंस से डिवाइड करूंगा, तो रूट L by C से डिवाइड करने का मतलब रूट C by L से मल्टीप्लाई. If I want to come to current from the voltage, I have to divide using the surge impedance, that is divide by root L by C, or you can multiply with root C by L. ये समझे? तो यहां पे ये इक्वेशन मेरे पास बन गई. Now current contains sin omega t. Sin omega t becomes negative after pi, that is after half cycle. So then your diode turns off. समझ गए? सर IGBT क्या होता है? बेटा IGBT मैं पढ़ा चुका हूं परसों के लेक्चर में, कवर हो चुका है IGBT, पीछे का लेक्चर देखिए. ठीक है. और RC वाले में एक्वा भाई मैंने बस ये बोला कि देखो साइन ओमेगा टी का इनपुट है. अब साइन ओमेगा टी 0 के पहले तो नेगेटिव रहता है, उस कारण से कैपेसिटर के पास कुछ नेगेटिव वैल्यू रहेगी 0 पे, क्योंकि 0 के पहले नेगेटिव साइकिल चल रही थी ना. अब 0 के बाद जब पॉजिटिव साइकिल चालू होती है तो आरसी सर्किट से कैपेसिटर पॉजिटिव वोल्टेज की तरफ चार्ज होगा, और जैसे ही वो थ्रेशोल्ड प्लस डायोड का वोल्टेज क्रॉस करेगा, क्योंकि थायरिस्टर को कितना वोल्टेज चाहिए? VGT. डायोड को कितना चाहिए? VD. जब कैपेसिटर के पास इतना वोल्टेज आ जाएगा तब SCR आपका ट्रिगर हो जाएगा. ऐसा मैंने बोला. ओके. तो कंडक्शन कंटिन्यूज फ्रॉम 0 टू पाई. तो एट पाई इफ यू फाइंड द वोल्टेज Vs 1 minus cos pi, V0 cos pi, this is 2Vs minus V0. And once the current is 0, inductor voltage is 0. What about diode voltage? Supply minus inductor minus capacitor. Inductor voltage 0, capacitor 2Vs minus V0. This is the supply voltage, diode voltage, which is negative. So diode is reverse bias. If you want the inductor voltage, you can do L di by dt. It is also coming as cos omega t. कितना आ रहा है? Cos omega t. तो steady state का मतलब क्या होता है? In these circuits, steady state means when the conduction stops, so the current and voltage becomes constant. ठीक है? Is that clear? तो देखिए capacitor is charging from V0 to 2Vs minus V0. The current is sine, which becomes 0 at pi. Inductor voltage is cosine. That also becomes 0 after current becomes 0. Diode voltage becomes negative. Till the time diode was conducting, voltage was 0. Once it stops conducting, it becomes negative. Now, if your capacitor is initially uncharged, put V0 as 0. You will only get one term Vs 1 minus cos omega t. Current will also contain only one term. Even now, beta, after pi, current reverses. So diode turns off. So at pi, Vc will become 2 Vs and VL will be minus Vs. Okay, VL will be minus Vs. So now the waveform will start from 0. It will go up to 2 Vs. Peak current is Vs root C by L. Inductor voltage is cosine. Diode maximum voltage will be minus Vs. आप बस ये समझ लो यहाँ V0 को 0 कर दिया है हर जगह. ठीक है, I have put V0 as 0. Now if my capacitor is initially charged to a voltage V0 and there is no supply, because of initial charging, capacitor will discharge. So when it has an initial voltage V0, which function will I use? Cos omega t. Initial value के साथ cos और steady state के साथ 1 minus cos. फिर अगर voltage में cos तो current में sin, voltage में sin तो current में cos. So cos omega t, so current will contain sin omega t. Again after pi current reverses, diode will be off, voltage of capacitor will be minus V0, and when current is 0, inductor voltage will be 0. So diode voltage will be minus V0. जब एक बार करंट बंद हो गया ना तो इंडक्टर का वोल्टेज भी 0 चला जाएगा, डायोड वोल्टेज माइनस V0 आएगा. तो कैपेसिटर वोल्टेज इज कोसाइन, but at minus V0 it will stop. Current is sine, at pi it will stop, and then diode voltage is also minus V0. कंडक्शन रुकने के बाद माइनस V0. ये देखो आज के फॉर्मूलाज मैंने सारे समराइज कर दिए आपके लिए. ठीक है, चलिए कम टू द डेली क्विज. व्हाट इज द मेजर एडवांटेज ऑफ GTO ओवर अ SCR? व्हाट इज द एडवांटेज ऑफ GTO ओवर अ SCR? बताइए. What is the advantage, beta? It can be turned off by a negative gate pulse. We don't need a commutation circuit. A triac can conduct in both directions and is triggered by a gate pulse. So VI characteristic and SOA appear in VI characteristic कौन से quadrant में आती है बताओ? You just now saw the graph. The characteristics appear in which quadrant? First and third. देखो VI characteristic की बात की गई है तो VI characteristic आपकी फर्स्ट और थर्ड क्वाड्रेंट में बनी थी अगर आपको ग्राफ याद हो. For DIAC and Triac, we always have the characteristic in the first and the third quadrant. ठीक है, but SOA is all four quadrant. तो ये क्वेश्चन में थोड़ा सा कंट्रोवर्सी है. SOA 4 क्वाड्रेंट होगा, VI कैरेक्टरिस्टिक फर्स्ट एंड थर्ड क्वाड्रेंट होगा. ठीक है, तो इसमें CD दोनों ही सही हो सकते. In a basic resistance firing circuit for SCR, the purpose of a series diode is primarily to. What is the purpose of a series diode? बताओ. सीरीज डायोड का प्राइमरी पर्पस क्या है मेरे भाई? प्रोटेक्ट द गेट फ्रॉम रिवर्स वोल्टेज. ड्यूरिंग नेगेटिव हाफ साइकिल डायोड विल बी ऑफ, so you cannot apply a negative pulse. नेगेटिव साइकिल में डायोड बंद हो जाएगा ना, नेगेटिव पल्स नहीं लगेगी. और सी तो हो ही नहीं सकता बेटा. इन रेजिस्टेंस फायरिंग अल्फा इज लेस देन इक्वल टू 90. आप 180 तक तो वैसे भी नहीं जा सकते अल्फा में. नेक्स्ट, in UJT relaxation oscillator, the time period between the firing pulses Now, what is eta? What is eta in this formula? इस फॉर्मूले में ईटा क्या होता है बताइए. What is eta? Intrinsic standoff ratio. Intrinsic standoff ratio. When an ideal diode is connected in series with a pure inductor across a AC source, the diode will. जब डायोड को इंडक्टर के साथ एक एसी सोर्स से जोड़ोगे तब डायोड क्या करेगा बेटा? What will diode do? It will never turn off because current is unidirectional. माने current never reverses. current पलटता ही नहीं है. Next, in a LC circuit with a DC source and a diode, the conduction period of the diode ends precisely when the inductor current. कंडक्शन पीरियड कब खत्म होता है? डायोड का कंडक्शन कब आपका रुकता है बोलिए? When does the conduction stop? When inductor current reaches zero and tries to reverse. For gate triggering circuit of ASCR, if gate power dissipation is a limiting factor and pulse width is less than 100 microsecond, which power rating is most critical to consult? For less than 100 microsecond, which power rating you will consider? We consider peak gate power dissipation, average if the pulse width is more than 100 microsecond. Average above 100 microsecond पे और below 100 microsecond पे peak. Next, which statement about triac are correct? देखिए MSQ है. Which statement about triac are correct? 2 SCR anti-parallel, yes. Fully controlled bidirectional, yes. It can be triggered in both direction, yes. Higher power than SCR, no. SCR has the highest rating among all the devices. Compared to conventional SCR, typically GTO has. GTO को compare करो SCR से. Come on everybody. Compared to SCR, GTO has higher latching current, higher gate current, poor turn off gain, faster switching speed. सब कुछ सही है. GTO हमेशा फास्ट होगा SCR के मुकाबले. SCR स्लोएस्ट है. ठीक है. In the context of diode circuit with energy storage element, which circuit can produce a sinusoidal current using a DC source? एक DC सोर्स से कौन साइनोसोइडल करंट बना सकता है बताइए? Only LC oscillator. LC oscillator produce sinusoidal current and voltage even though the supply is DC. चलिए, try this question बेटा. Try this question. टर्न ऑफ गेन समझाया तो था बेटा. टर्न ऑफ गेन का मतलब होता है IA अपॉन IG. टर्न ऑफ करने में कितने एनोड करंट पे आप ऑफ कर रहे हो और उसके लिए कितना गेट करंट चाहिए. तो पुअर गेन का मतलब है यू नीड वेरी हाई गेट करंट टू टर्न ऑफ आ GTO. ठीक है. चलिए ट्राई दिस. ट्राई करिए. आया भाई इसका आंसर? देखिए, SCR has a latching current of 40 milliampere. Okay. Now SCR current is composed of two parts, I1 and I2. Now you assume the SCR to be short circuit. Now I1 is the RL circuit. So current is V by R. 1 minus, it is a charging RL circuit, where tau is L by R, 0.4 millisecond. Now you are applying a pulse of 50 microsecond. So at t equal to 50 microsecond, what is I1? 0.2. Okay. (23.5 milliampere). But beta, by the time the gate pulse ends, your SCR should reach the latching current. जब गेट पल्स 50 माइक्रोसेकंड पे एंड हो रहा है, तो at 50 microsecond, thyristor current should be equal to latching current. Then only it can turn on. I2 will be, what is R? Six zero 0.6. तो बेसिकली देखो, इंडक्टर का करंट चला गया 23.5 मिली एम्पियर, बाकी का जो 16.5 है वो अगर मुझे दे देगा R2 तो मेरा काम बन जाएगा. एट 50 माइक्रोसेकंड SCR करंट विल रीच द लैचिंग करंट. चलिए ट्राई द नेक्स्ट वन. You need to design the value of R if the latching current is 10 milliampere. Try this. देखें भाई, देखो, first of all you consider this to be short circuit. Now this is I1, this is I2. The voltage of inductor will become 100 volt. So by integrating I will get this. Now I want to turn on within 5 microsecond. 5 micro by 0.1. So this is 5 milliampere. Now the total current should be 10 milliampere. So I2 will be 10 minus 5. 5 milliampere. So what is the value of R? 100 by 5 milliampere. 20 kilo ohm. So you can take a resistance less than 20 kilo ohm, but do not take more than 20, because less than 20 means more current, which means SCR current will be above the latching current. That is fine. It should not be below latching current. बात समझ रहे हो? SCR का करंट लैचिंग के ऊपर जाए कोई तकलीफ नहीं है, लैचिंग के नीचे नहीं जाना चाहिए बेटा, वो इंपॉर्टेंट है. चलिए नेक्स्ट वन, सिमिलर क्वेश्चन. The latching current is 4 milliampere. What is the minimum gate pulse width? What is the minimum gate pulse width? Consider this as short circuit. Point 1 di by dt. When you integrate, current is 1000 t. So t will be 4 microsecond. ठीक है? t 4 microsecond. चलो अगला ट्राई करो भाई. अगला ट्राई करो. ये सारे पैरामीटर्स आपको निकालने हैं. 4 क्वेश्चंस हैं इसमें. देखो भाई, कंडक्शन टाइम ऑफ द डायोड पूछा जा रहा है. नाउ वी नो इन अ एलसी सर्किट डायोड कंडक्ट्स फॉर हाफ साइकिल. हाफ साइकिल माने पाई बाय ओमेगा नॉट, और यू कैन से पाई रूट LC. तो हाउ मच? वन 172 microsecond. Diode peak current, when you know the initial and the steady state value. याद है ना what equation I wrote? Based on the initial condition, 1 minus cos, based on the steady state value, based on initial cos. Current came out as Vs minus V naught root C by L. So beta, you must know how to write the equation of LC oscillator. This I have covered in my networks course. So 300 root C by L. So 300 under root 0.3. 164.316. steady state voltage, it is happening at pi 2 Vs minus V naught, 700. Diode voltage, supply minus capacitor minus 300. 400 minus 700 minus 300. ठीक है, ऐसा बन जाएगा. चलिए, नाउ आई विल कम टू द असाइनमेंट दैट आई गेव यू yesterday. कल वाला असाइनमेंट करेंगे. dv by dt protection is achieved using RC circuit across SCR, which is Nubber circuit. SCR has a quarter cycle surge current rating. So quarter cycle means I will take half of T by 4, T by 8. For one cycle, I will take T by 2. So I will be 1500. And what about I square T? 3000 square into T by 8 or 3000 square by 8F. F is 50. So 3000 square by 400. 22,500. 22,500. Okay. Pulse triggered SCR, average power dissipation, maximum power dissipation. Now beta, average power is maximum power into duty cycle. Why? Think of the waveform like this. When you are applying the pulse, then there will be power dissipation. जब आप पल्स लगाओगे पावर आएगी. फिर आप पल्स हटा दोगे. When you remove the supply, power dissipation will become zero. Like this. T. T is 0.1. John by T. So T on is 0.1 T. 0.9 T. It will be 1 by 9. Okay. Latching current is 2 milliampere. Minimum gate pulse width. अभी ऐसा ही क्वेश्चन हमने देखा ना. तो SCR is assumed to be short circuit. .833. So it will be 3.33 microsecond. C. Correct? UJT employed for triggering eta is given, VBB is given, ammeter voltage. So for triggering beta, we need this, which is VP. ट्रिगरिंग के लिए एमीटर पे VP के बराबर वोल्टेज आना चाहिए. So I will choose 13.1. 13.1 that is above 12.8. मैं 12.8 से बड़ा चुनूंगा. Junction capacitance is given. Limiting value of charging current is given. If capacitor of 0.01 microfarad is connected. Now when you are connecting a capacitor, the equivalent capacitance will be 10 nanofarad plus 20 picofarad. 0.01 microfarad, na, it is 10 nanofarad. Now, the limiting charging current, that is the maximum charging current, is 15 milliampere. So, what is dV by dt? 15 milli by 10 nano, 1.5 volt per microsecond. सिंपल C dV by dt चार्जिंग करंट होता है, उसका मैक्सिमम वैल्यू गिवन है. नेक्स्ट, maximum value of di by dt and dv by dt of the SCR in the following circuit. अब ये वाला ध्यान से देखना. First of all, beta, how to solve this type of question? Initially, SCR is off. Take L and C as uncharged. Okay. So, thyristor is off. Inductor uncharged means the inductor will be open, capacitor will be short. Now, beta, the voltage across the inductor will become equal to supply. So, what is the maximum inductor voltage? It is 440, which you can write as L di by dt maximum. So, when the inductor voltage is maximum, I get maximum value of di by dt. 440 1.76 ampere per microsecond. Now, beta, when the current will start to flow, when actually your current starts to flow, current will flow like this. Because SCR is off. Okay. So, thyristor voltage is 15I plus Vc. Correct? Now, you need the maximum rate of change of thyristor voltage. 15 di by dt plus dvc by dt. Now, what is dvc by dt? It is current upon C. So, now maximum di by dt is 1.76, but that time current is 0. है ना? Initially current 0 था. So, 15 into 1.76, 26.4. तो ऐसे होता है. माने entire question is solved in the initial condition when your inductor capacitor are uncharged. So 1.76 and 26.4. समझे? बहुत प्यारा question है. It is completely related to the case of transients. Okay? For SCR, gate cathode characteristic, this I have taught you today. Gate cathode characteristic, माने this is the SCR characteristic. Do not consider it as the load line. So basically, it is a straight line. So Vg upon Ig is 440. Now, ES is 20. Pg is 0.5. Okay? Now, Pg is Vg Ig. And from here, I know Vg is 140 Ig. So So I can write 140 Ig square is 0.5. So Ig will be 0.05976. So Vg will be 8.366. ठीक है, 8.366. Now how to find the resistance? We can write Vg as ES minus IGRS तो 194.66. ठीक है, इस टाइप का क्वेश्चन आपका बनता है फ्रॉम द गेट कैथोड कैरेक्टरिस्टिक. Next beta, the junction capacitance used in the circuit is 15 picofarad. Limiting charging current and critical dV by dt is given. Value of CS. So what we know, Vs is not given. Now I will say CS plus Cj into dV by dt is charging current. बट मेरे हिसाब से ना यहाँ पे Vs दिया जाना चाहिए था, क्योंकि Vs बाय RLC होता है. ये चार्जिंग करंट तो सिर्फ आपके SCR का होता है. मिनट में एक बार चेक कर लूँ. एक्चुअली Vs शुड बी गिवन. यहाँ पे ना यार ये डेटा मिसिंग है, मेरे पास वैल्यू तो नहीं है. 200 वोल्ट पर माइक्रो सेकेंड should be Vs by 50. So C will be Vs by 50 into 200, 10,000. Okay. माइक्रोफैरेड. तो ये चीज मिसिंग है, डेटा आपको यहां से सॉल्व करना होगा. नेक्स्ट, द सोर्स वोल्टेज इज 100 वोल्ट, लोड रेजिस्टेंस इज 10 ओम. It can withstand a value of dV by dt 50. Discharging current is 2. So now beta here you can directly use that this is your load resistance. So 50 100 by RL C. C equal to 100 by 50 to 10.2 microfarad. Now discharging current is Vs by R, which is how much? 100 by R. This is 2, so R should be 50. C option. 50 ohm and 0.2 microfarad. Thyristor has a thermal capacity, thermal resistance, maximum power dissipation. It can withstand for 1.1 second temperature not exceeding 50 degree centigrade. Now beta, what happens is thermal time constant is thermal capacity into thermal resistance. जूल अपॉन वॉट से आ जाता है 0.1925 second. Now, beta, temperature is a first order system. The increase in temperature follows a first order system. So, maximum temperature is 50 degrees centigrade. In 0.1 second, it should reach. Or for 0.1 second, the temperature 0.1 सेकेंड पे टेम्परेचर 50 आना चाहिए, बट मैक्सिमम कितना जा सकता आएगा, तो आई कैन कैलकुलेट पावर. फाइव मिली एम्पियर, लेकिन थायरिस्टर का करंट है ना बेटा, चार्जिंग करंट, वो दोनों कैपेसिटर का टोटल थोड़ी ले सकता हूं मैं. I cannot say that take the total capacitance and then use the charging current of SCR with it, because that current belongs to SCR, not the parallel capacitor. वो करंट पैरेलल कैपेसिटर का थोड़ी होगा. एक मिनट, तो मिस कर रहे हैं. नाउ टीजे मैक्स ही तो मिसिंग है. नाउ टेम्परेचर शुड बी 50 डिग्री इन 0.1 सेकेंड. यही कंफ्यूज हो गया था. मैं सोच रहा था ये भी गिवन होना चाहिए. कायदे से पूरी इक्वेशन में एक ही तो अननोन है. बेसिकली ये जो टेम्परेचर राइज होता है ना, दैट ऑल्सो फॉलोज अ फर्स्ट ऑर्डर इक्वेशन. तो पावर विल बी टेम्परेचर अपॉन थर्मल रेजिस्टेंस 160.2. 160.26. हाँ जी, थायरिस्टर shown in the figure has a I square T rating 20 ampere square second. Terminal A gets short circuited to the ground. Okay. Fault clearing time so that SCR is not damaged. Now what is the current? V upon 1 plus 10 parallel 1. 10 by 11, 21 by 11. Okay. 11 by 21, 230 root 2 sin omega. So what is the maximum current beta? Maximum 230 into root 2 into 11 by 21, 170.38. Now I square t is 20. So what is the time? 0.688 millisecond. So basically, in this time, you should clear the fault, otherwise SCR will be damaged. Just a moment. Okay. In this time, you should be able to clear the fault. Okay, beta. Now, this is your assignment of the day, which we will discuss tomorrow. And tomorrow, I will start with the rectifiers. कल मैं rectifiers के साथ start करूँगा. Ready रहिएगा. Okay. So, thank you everyone. Have a great day. And come prepared with the single phase half wave rectifier tomorrow. कल single phase half wave rectifier तैयार करके आइएगा. एंड ऑल द यूट्यूब स्टूडेंट्स, बेटा आपको मैंने बता दिया है पीडीएफ कहाँ पे मिलेगा. ठीक है, थोड़ी देर में पीडीएफ अपलोड हो जाएगा. अदर देन दैट बेटा, राइट नाउ यू आर गेटिंग 70% ऑफ ऑन RIB. लेट मी शो. तो बेटा इफ यू गो टू द वेबसाइट, पीडीएफ आपको यहाँ पे अपलोड मिल जाएंगे फ्री डाउनलोड्स के अंदर. ठीक है. And if you go to this beta gate batches live, ठीक है, here you can see the rank improvement batch. On this batch you are getting 70% off using YT70, and on this batch also beta you are getting 70% off on YT70. और नेक्स्ट ईयर के जो कोर्सेज हैं रिकॉर्डेड कोर्सेज, इन सभी पे अभी 30% ऑफ चल रहा है. आपके रिकॉर्डेड में अगर आप जाओगे, ये जो नए कोर्सेज आए हैं इन सभी पे 30% ऑफ है यूजिंग EB30. और इस साल का कोई भी लाइव कोर्स लोगे तो 70% ऑफ है यूजिंग YT70. तो लाइव कोर्स में 70% ऑफ, रिकॉर्डेड कोर्स में 30% ऑफ. कोड है EB30. टेस्ट सीरीज पे 70% ऑफ है. कोड यहाँ पे पहले से लिखा हुआ है अंकित ESE, इसी से 70% ऑफ मिल जाएगा. चलिए, थैंक यू एवरीवन. Aqua bhai, I might visit Indore at the end of January or beginning of Feb.